So we have been tracking diligently since the last lecture, and up here we can now also see that we have everything green. Now there's a little gray area here, but don't worry about that for now. We're gonna get into camera solving. Now to do this, we go to the solve panel on the left, but we don't want to click tripod here now, because we are not in a place where we are standing still. We actually are going to move in this space. Now we're going to tell Blender that it should refine the keyframes, so we go to keyframes and then we say refine focal length, optical center, and radial distortion. And now let's see what happens if we click solve camera motion. Now you can see that the solve error is extremely high, and that's very often due to the keyframes. The keyframes are the frames used to initialize the camera's motion reconstruction, and if they're not selected correctly, this can lead to a lot of problems. Now in any case, it often helps quite simply to choose a few keyframes by yourself. For example, we have 152 and 190, and these look pretty compatible. And I took my picture here with my cell phone, so I don't know the focal length of my camera. But if you took the picture with a camera that you know the focal length of, then you can also just uncheck the box here and set the whole thing by yourself. Now accordingly, you can see that the focal length has been calculated by Blender now, and it says 34.38. And even if we play around with that, maybe set it to 34, we might have a chance to get a better solve here. Now we have a solve error of 0.64 pixels, and that might be good, but the solve error itself doesn't say that much yet. We can test whether the solve error says anything, and if everything works well or not, by simply having the whole thing reconstructed in 3D. Now to do this, we want to click set as background here, and then the video will simply be used as a background video in our camera. And now we want to say set up tracking scene, and then a cube and a plane will be added to our scene. And if we can now move here, it all looks somewhat coherent, and then that's the track we can actually work with. When we look at this, we can see that it looks relatively alright. We don't have any big jumps anymore when we step out of the camera, and we can also see that we have this whole geometry here now. These are the points that are calculated by Blender. It actually works quite well. However, the orientation in our room is not exactly optimal, so somehow it's not quite as coherent as we would like it to be. Now, how can we improve this? The answer to this is very simple. We go to the so-called orientation options down here, and we can now set where we want our world origin to be, so where the center and the intersection of all three axes is. Now, before we do that, we can actually convert our 3D markers into a mesh as well. That means we can select our markers here by pressing A, and then we say 3D markers to mesh. And then these tracks are sort of created as an object for us when we go into the object mode. Now, if I press F now, we can actually make a face out of it as well. And we really don't want that, but theoretically one could do that now on the basis of what we have right now, because we have a good track and everything works well. So it's exactly at this point that I would like to model something, for example, and then we can even go into the 3D viewport and do that accordingly. But enough talk for now. We want to put the whole thing in the right direction, and that's what we're planning to do. Now, in order to make the whole thing possible, we first have to select a point of origin, and we just have to decide where that is. One point is supposed to be the center of our world practically, and this could be this point, for example, simply because it is so nicely located in the middle. So here we say set origin, and now this is our new center of the world, and we now have to choose our floor. Now we have to select 3 different trackers for this. Let's choose this one, and this one, and just say floor, and now the whole thing is pretty much aligned. However, this is still a little bit too big to adjust the size of our object here, so the simple trick is that we select 2 markers, and we say set scale here, for example, to 3, and then we press set scale, and now everything is a bit smaller in comparison. It makes perfect sense though, because we've just selected 2 points, and then we entered a larger value for the scales than before, and a larger value between the 2 points in relation, and then you get smaller geometry as a result. Now, we can look at the whole thing again, and it actually looks as if our cube is here on the floor. We could go around it, everything seems to fit, and we now have a solve error of 0.6 in general. Anything below 1 is usable in some way, and in fact, I shouldn't rely too much on the solve error alone, because sometimes you can have a safe area of 0.1 or something, and then it's just not accurate. But in the end, for example, on this video, is that you can have a very low solve error, but it wasn't accurate enough, and that wasn't what I wanted, even though I have a low solve error. So you just gotta take the solve error as it is. If everything works, then I can push the solve error down a bit to perfect it, but it's not an absolute measure of things. Now here we have a cube in our scene, and we move this cube around, and we're approaching this cube. However, it's important to understand that we now have changed the orientation of our scene, and if we look at the whole thing now, it's no longer true. We'd have to delete all the tracks here before we do it all over again. So that means I'd have to reselect all the tracks and do it again, but I'm not gonna do that now. One thing that's also interesting is that you can see this curve here, so to speak, and this curve is the path that the camera is going through here, and that's actually the camera solver. So in the end, this is nothing more than an automatically added object constraint, and this curve is very much the movement that I made with the camera in real life, so it has a few imperfections here as well. The lower the solve error, the more accurate the camera movement is going to be. I mean, I think it's accurate. It was a few days ago, so I can't remember. Alright, so we have a good camera solve, and you can see our geometry here, and we can build something out of this now. And we're gonna look at the lighting and the way that works dynamically in the scene. We'll look at that in the next lecture. But I hope this lecture has helped you. If so, please give it a 5-star rating. It would help me a lot, and I would be very happy if you did. And I'm gonna see you in the next lecture. Alright, see you then. Bye.